right, page 113 in your textbooks. And we were working on finding the equations of lines. Not just graphing them now, but finding the equations of lines given certain information. Sometimes given a slope and given a point, or sometimes given 2 points. And practiced with that quite a bit. Also had a couple of equations that you would have graphed on page 114, numbers 8 and 11. But mostly making up some equations. Page 113, numbers 7, 10, 11, and 13. Page 114. The 8 and 11, and then 30, 32, 35, 36. Good. And there's the work, and there's the graphs. And good. All right. There's 8 and 11. There's the work for 8 and 11. And good. And you did have some of the work here. 10, 11, 13, 30, 32, 35, 36. Okay. All right. It was just the graphs then that we left. All right, number 7, you were given the point 5, 6, you're given the point -1, 4, and anytime you're given 2 points and you want to know the equation, let's backtrack. Class, what 2 things do I have to know in order to write the equation? Slope and y-intercept, right? So if I know 2 points, what's the easiest thing to find just right off the bat, class? The slope, right? So we need to start with the slope formula, which is, Noah, m equals Now, I guess technically, if you said y1 minus y2 over x1 minus x2, it wouldn't technically matter because it doesn't matter which order these are in as long as they stay together. The 2's minus the 1's or the 1's minus the 2's, but this is the conventional way to write it. So given the point 5, 6, given the point -1, 4, which y value did you start with? The 4. So you said 4 minus 6 over 1 minus 5, which gave you a numerator of 1. Well, initially -2 and a denominator initially of 6, which then you cancel the negatives and reduce to get 1/3. So there's our slope. Now, once we know the slope, that's half the battle. The other thing we need still, though, Maddie, remind us again, is the... And to get the y-intercept, I suggested you just start by writing out. And then we can plug in everything but the b, that y-intercept. We just found the slope. We know that's 1/3. What do I plug in for the y and the x, though, Maddie? Good. You plug in one of the 2 points. Maddie picked the point 5, 6. She could have picked the point -1, 4. Happens to not like negatives. I don't blame her. So she puts the 6 where the y is, the 5 where the x is. Though I did suggest, if you have a fraction here, Maddie, to write the x as, good, a fraction. So 5 over 1. So we get 6 is equal to 5/3 plus b. Unfortunately, nothing cancels like we would have hoped. Got a couple options. Maddie, what do you do when you get to this point? Because you got a couple options available. What do you personally do? Okay, so you do go ahead and clear the fraction. Now you multiply everything by 3 to get... There we go. We get rid of the 5 by making it to get... And at the same time, let's get the b by itself by dividing away the 3. So there's our b. We found the m. We now found the b. What's the equation bracket? And how many have this equation for number 7? All right, Maddie, good gentleman question. All right, tell you what, gentlemen, let's stay with you as we look at number 10. We've got the point -5, -1. We've got the point 2, 7. And Noah, I'm going to have you take the whole problem for me. Walk us through. What do we need to do?
We need to find the slope.
Good. That's unfortunate. All right, then what?
You put y equals minus 50. Then you get 7 equals 2 times 8 over 7.
Well, 8 over 7 times 2 over 1, technically, just try to keep it in order. But anyway, yes?
And then you get
get?
16 over 7.
All right, so 7 equals 16/7 plus b.
And then you bring it over as a negative.
So negative 16/7. But if I'm going to write this as negative 16/7, I should also rewrite my 7 over 1 as let's multiply top and bottom by 7.
49 over 7.
Good, this becomes 49/7. So 49/7 minus 16/7 gives me a b value of
33 over 7.
good 33/7. There's the b, there's the m. What's the equation?
Y equals 33. Wait, no.
Remember y equals mx plus b. What's the m?
8 over 7. Plus.
Well, don't forget the x.
And plus 33 over 7.
There we go. Does that make sense? We write y equals, and instead of the m, actually write what we found m to be, x plus, and then write what we actually found b to be. Now, if b were a negative, I wouldn't write plus negative 33/7, for instance, just say minus 33/7. But there we go. How many have this equation for number 10? Ooh, nobody. All right, it's kind of ugly, I'll grant you that, okay? It's hideous work, but it is correct, and we need to be able to work with the challenging numbers. How about number 11? This one worked out a little bit nicer. We had the point 2, 1, we had the point -2, -3, and Brecken, take me all the way through this one. Okay? Two negatives in a fraction? All right, there's the m. Now what? Well, careful, I need to plug in a y value. There we go. So if this is your xy that you're picking, make sure 1 equals 1x. And there we go. How many had this for number 11? A little bit more straightforward problem there. Quick questions. All right, and then number 13. Given the point 3, -3, and -3, 2. Now, Maddie, you got the first one, but you've missed the last couple, so I'm going to have you go ahead and walk us all the way through this one, starting by finding the 2 minus -3. Okay. I got 2 negatives, but also yeah, a little bit of canceling there. Remember, guys, signs, negatives can cancel numbers, and that makes it a little bit easier now, Maddie, because I don't have to multiply everything by 6. I can multiply everything by 2 to get. I'm sorry? So the equation, and there we go. And we get this for number 13. Get that for 13. Okay, a couple of you did that time. Questions. Now realize all of this practice was 2 points, 2 points, 2 points. You had to find the slope first, right? Remember, Remember, Maddie, the other day where I gave you the slope and the y-intercept and it really threw you off? Don't let easy things throw you off. If I gave you the slope and a point, you start here, right? If I already gave you the slope and a point, just start here. Okay, so don't let easy throw you off. Certainly if I gave you the slope and the y-intercept, bam, just write the answer, right? So don't let easier things throw you off. Turn the page. Page 114. Let's deviate from finding equations for a moment and review graphing equations. You had number 8 and number 11. On page 114, what was the equation for number 8, Brecken? 3y over 4
minus 2x equals 6.
So you said 7 or 6?
6.
6. All right. Well, that's a perfectly ghastly looking equation. What in the world should we do, Brecken? For one thing, let's make it look less ghastly. It's a good word, by the way. You should use that more often. Not when you're talking about your sister, though. That would be not good. You'd look pretty ghastly when she was done with you. Anyway, I'm sorry, what? Yeah, let's multiply everything by 4 right up front. I hate looking at fractions. All right. Now, we've got 3 options. We could either graph by table, we could graph by intercepts, or we could graph by slope-intercept form. What do you want to do? Okay. So for the x-intercept, remember we have to plug in. And when we do, what do we get for x? -3. All right. And for the y-intercept, plug in 0 for x. What do we get for y?
8.
All right. So I'm just going to show a quick sketch here for sake of time. We plot our x-intercept at -3 on the x-axis. Put our y-intercept all the way up here at 8 on the y-axis. We should get a line that comes down like this for number 8. How many had a line like that for number 8? Intercept at -3, intercept at 8. Did you use the intercept method, Maddie? All right. Noah, what did you do? Intercepts or table or slope-intercept form?
I think it's slope-intercept form.
Okay. So for you, if you'd gone slope-intercept form, we would have moved the 8x over as a positive to get 3y equals 8x plus 24, right? And we would have then divided everything by 3 to get y is equal to 8/3 x positive 8. You should have plotted your y-intercept at 8, and then, looking at this, Noah, you'd have had to gone up 8 and forward 3. But that probably doesn't fit on your graph grid. So you have to reverse the process. And I think you did this, if I'm looking at your paper correctly. You went down 8, but you still went forward 3, didn't you? So remember, everything has to be in reverse. If you're going to go down instead of rise, you also have to run the opposite way, run backward 3. And that's the downside of trying to think in reverse sometimes. So you got half of it reversed, you just got to reverse the other part. All right, let's take a look at the next one then. Number 14, or number 8. Number 11 was 3y. -2x is equal to 6, I believe. Yes. And Brecken, this one, what did you do? Do you remember if you did intercepts or slope-intercept form? Intercepts, all right. What are the intercepts? All right, so plug in the 0 for the y, get -3, all right. All right, so once again, we start with an x-intercept of -3. This time a y-intercept of just 2, and should have had a line that looks something like that on our paper. Did we get a line like this for number 11? Did not. Okay, Noah, did you, I assume you did slope-intercept form again, right? No, you did intercepts? You just botched the intercepts.
Yep.
Questions? Be careful. Careful with signs, if I'm not mistaken. Probably a sign error. No? What were your intercepts?
2 on the top and 3 on the bottom.
You had 0, 2, and 3, 0?
I
Or 2, 0, and 0, 3, something like that?
Yeah, 2, 0, and 2.
Okay, make sure we're careful to plug in for the right thing. If you write the 0 in the x spot, make sure you actually plug the 0 in here to get 2. If you write 0 in the y spot, make sure you actually put it here to get your negative 3. Okay? All right, let's take a look at the numbers 30, 32, 35, and 36. Back to finding equations. Number 30, what were we given, Maddie? I'm sorry? Oh, okay, so this is when we can literally just write down the answer. Maddie, what's the slope? 3. What was the y-intercept? 0, 4. All right, so what's the equation, Maddie? Y equals 3x plus 4. Could not be easier on number 30. Did we get that answer, gentlemen? Question, Noah.
I forgot 3x.
Number 32. We were given a couple of points. So this time we had to find, class, the... What first when you're given 2 points? Slope. Find the slope first. What do we find the slope to be, Brecken?
Negative 4 plus 4 over 0 over 1.
Or in other words,
0.
so when we write down our y equals mx plus b, Brecken, and we write what for the y? Ooh. Whoa. A y value. We need a y value, Brecken. On number 32? Negative 4 would be a y value. We know that the m is 0, and which x value? The 3 goes with the negative 4 plus b. But it really doesn't matter which x value I pick, because when I multiply, it's going to become 0. And it didn't matter which y value I picked, it was going to be negative 4. So in other words, b equals negative 4. Now, I know the b, I know the m. Going into y equals mx plus b, Brecken, we would get? Right, y equals 0x plus negative 4, y equals 0x negative 4, y just equals negative 4 if the slope is 0. And how many got y equals negative 4 or y equals 0x negative 4? Questions? Number 35, Noah, they gave us the slope and a point. So I need to find a slope this time. All I need to find is the y-intercept. Because class, you need what 2 things to graph? Or to know an equation? Slope and y-intercept, right? I know the slope already. I just need the y-intercept. So I'm going to start this time, Noah, with... On all those other homework problems we did earlier, we started by finding the slope. But we ain't got to do that this time because I already know the slope. So I already know that the slope is 1/6. I need to plug in my y and my x. Noah, what's the y? And the x? Good, I like that you said over 1. We can do just a little bit of to get... Right, so we end up with negative 3 is equal to 2/3 plus b. And then I believe you like to bring it over, correct? So let's write this as 3 over 1. Let's bring this over as a negative 2/3. But in doing so, I need to rewrite my negative 3/1 as negative 9/3. It'd actually be negative 3 first, but negative 3/1 sounds cooler. All right, so what do we get for our b? Negative 11/3, right? If I take 9/3 and then I take 2 more thirds, I've taken 11/3. So there's my b. I already knew my m. I was given that. What's the equation, Noah?
Y equals 1/6 negative 11 over 3.
There we go. And did we get this equation for number 35? Yes. Sort of. How do you kind of get that equation?
I got
Negative 3 and 2/3. Okay. You know, I guess that's fair. Since you have the whole number here, negative 3, take away 2/3 more, that's taking away 3 and 2/3 would be acceptable. But improper fractions more preferred unless we're actually graphing, but it's not necessarily wrong either. All right, then Brecken, you said yes. You had the same thing, okay? And then you had it outright. Good. And then number 36, once again, when given 2 points, class, we first have to find the slope. Once we have the slope, we can use that to find the y-intercept. Your equation should have been y equals negative 10 ninths x, negative 43 ninths. Or y equals negative 10 ninths x, negative 4 and 7 ninths. Did we get that answer for number 36? Yes? No? No? Okay, let's take a look at it real quick. Did you get the correct slope of negative 10 ninths? Okay, so we got the right slope. Let's pick up there. Y equals mx plus b. Brecken, which point did you plug in? 2, negative 7 or negative 7, 3?
3, 7 over 7.
The negative 7, 3. So you put the 3 in for the y. You put the negative 7 over 1 in for the x. And of course, we already found the negative 10 ninths slope. You set it up this way? Or did you get this negative 7 and the 3 in the wrong spots? Got them in the wrong spots. Noah, did you have it set up this way?
I had negative 7 and negative 2.
All right, so you put negative 7 right here and 2 right here? Okay, so we already found Brecken's mistake. He got his x and y switched backwards. Let's go with yours then and see if we can find your mistake very quickly. You had this set up just like that, correct? All right, so this became negative 20 ninths, which moves over as a positive 20 ninths. Now you cannot say, because the signs are different for one thing, also this is already improper, you can't make this mixed number, right? You've got to rewrite this as negative 63 ninths. And when you rewrote it, I'm guessing we didn't have 63 ninths. You rewrote it, correct, as some number of ninths? You tried to work with it as negative 7 plus 20 ninths? Or did you perhaps say negative 7, positive 2, and 2 ninths? Okay, you could do that, right? But you'd have to borrow. You'd have to say this is negative 6 and 9 ninths to get negative 4 and 7 ninths. All right, so in working, I would just go improper fractions. It's probably going to be easier in the long run. Or do what Mehdi does. Clear the equation of fractions first. You don't even have to mess with them. Might be the better way to go. All right, some quick classwork for you. Set your books aside. Have a sheet of graph paper out, if you would, please. And I want you to graph the following equation using slope-intercept form. Okay? Graph the following equation using slope-intercept form. X, negative 3y, equals 15. X, negative 3y, equals 15. Use slope-intercept form to graph. Make sure you manipulated the equation correctly, first of all. Bringing the x over, or double switch with the 15. And dividing by either 3 or negative 3, depending on what you did in the first step. How many have this equation? Y equals a third x minus 5. All right, Noah, question. Be careful as you manipulate things. All right, do we get this line? All right, questions? All right, now I want you to find the equation of a line that has a slope of -3/2 and goes through point E, which is 2, -5. Obviously, graphing would be easy. I want the equation of the line, not just the graph. So don't have to do the graph. Would be easy if you wanted to. I want the equation of the line. Do we get this equation for the line going through point E? All right, we've got 2 points, G and B. G is -4, 4, B is -8, -7. Again, we could plot the points, graph the line easily enough, but I want the equation of the line through those 2 points. There's the look of the line, not that it matters. What's the equation? Clear desk except for a clean sheet of paper, straight edge, and a pencil. Clean sheet of paper, straight edge, and pencil. Gavin, the quiz is in your mom's inbox. So I emailed the quiz to her. She'll need to print that out for you. Of course, after you finish the quiz, have her email it back to me. Clean sheet of paper and a pencil. Paper's for a cover sheet. Don't write anything on the paper. You'll complete the quiz on my quiz copy. When you get your quiz, put your first and last name at the top, along with today's date, which is 2/23/21. 2/23/21. 2/23/21, today's date. Let's take a look at the quiz together. Number 1, number 2, very straightforward, you're finding slope. Number 3 and number 4, I've given you a slope, I've given you a point, find me the equation. in slope-intercept form. Number 5 and number 6, I've given you 2 points. Find the equation in slope-intercept form. And number 7 and 8, I want you to rewrite each equation into slope-intercept form, then graph the equation. Make sure you mark and label your axes appropriately. All right, you may begin. finishing up here in the next couple of minutes. Let's go ahead and move on in our notes. If you haven't, if you need a little bit more time, pause the video for just another minute or two. We should be just about finished with that quiz if you're not already done. Next section, your notes. As we talk about lines, so far we've been primarily graphing line, right? Or sometimes on the same grid, on the same Cartesian plane, we may graph a few different lines together. And we've noticed a couple of times, class, that lines run beside each other at the same rate. They never intersect. And you'll remember from past classes that lines that never intersect are called parallel lines. Parallel lines. I want you to go ahead and let's talk just a little bit about these, though we have already discussed them in the past. Parallel lines. First of all, they never intersect. That's not new to you. Should be something you recall from the past. But the reason they never intersect is because they slant the same way. Or in other words, to use a term that we've recently learned in this class, parallel lines never intersect because they're going to have the same slope, right? And that's something I've already pointed out before, so this really isn't too terribly new. They're going to have the same slope. And that's what we need to associate in this class. Lines are going to be parallel if they have the same slope. I want you to consider for a moment this line. Y equals negative 4x plus 2. And this line, y equals negative 4x plus 5. Notice just by looking at the equations of the lines, you can tell both equations, class, have what slope? Negative 4. So therefore, because the slopes are the same, these two lines must be parallel. Because, class, they have the same slope. And if lines have the same slope, then they are parallel. What would be another line that would be parallel to both of those, Noah?
Negative 4x positive 6.
Okay, y equals negative 4x positive 6. Maddie? Y equals negative 4x positive 1. Brecken? All right, y equals negative 4x, negative 25. I thought you were going to say negative 25 million. And he would be right. It doesn't matter what number is here. It could be positive, it could be negative 25/73. Doesn't matter what comes after here as long as the slope is negative 4 because they'll have the same slope. How about this though? 3x positive 2y equals 6 and 6y is equal to 12 negative 9x. It's a little harder to tell if these are parallel or not, isn't it? What would be the key then? Get them into slope-intercept form, right? So let's start here, class, by moving over the
6. Or
the 3x as a negative to get y is equal to, and then divide everything by 2. I really don't even care what it comes out to. I can see what the slope is. Let's do the same thing here. Let's flip-flop a couple numbers here to get 6y equals right, remember the x comes before the constant, right, in slope-intercept form, and then also divide everything by 6. Again, I don't care about anything but right here. What does this reduce to, class? Negative 3 halves. That's what we have here. Yes, the lines are parallel. Does that make sense? Get slope-intercept form. What if we were told that we had a line that went through 2, 3, and negative 4, 5, and we had another line that went through negative 1, 7, and negative 4, 8. And the question is, would the line through these points be parallel to the line through those points? Well, how would I find out? I would need to find the slope, right? I don't even necessarily need the equation. I just need the slope. let's find the slope here very quickly. In the top class,
2.
5 minus 3 in the bottom,
-4/-2.
which would give us
2 over -6.
2 over -6, which reduces to
1 over
-1/3. All right, let's find this slope. In the top, we could write 8 minus 7 in the bottom,
4 plus 1, or
-4, minus -1 or plus 1 gives us
1 over -3.
1 over -3, that's -1/3. Yes, the lines would be parallel. Make sense? So a lot of different ways it could be presented to you to decide, are the lines parallel or not? But bottom line, class, if they have the same slope, then the lines are parallel. There's another relationship that you talked about in your junior high days about two lines. It was said two lines could be parallel to each other. It was also, pretend that's parallel, two lines could also be intersecting each other, but frankly, that's everything but parallel, right? If they're not parallel, maybe laying one on top of the other, he's still kind of parallel, then they'd be intersecting, but there was a special type of intersecting lines. Do you remember what they were? They would intersect to make perfect 90-degree angles with each other. Remember that? Perpendicular lines, right? Perpendicular lines were extra special. The idea being here, if you had a line like this, the perpendicular line, think about it. To be perpendicular, one's negative, the other would have to be positive, right? To be perpendicular. Also, however much this one rises, then runs, this one would have to run and then rise. Do you see that? So the rises and runs would have to be switched up. And one would have to be negative, one would have to be positive. So in your notes, big long word, perpendicular. Good news is it's spelled the way it sounds, perpendicular. Perpendicular lines are exact opposites of each other. And to be exact opposites, they are negative reciprocals of each other. That is to say, they have negative reciprocal slopes. The slopes are negative reciprocals. Perpendicular lines have negative reciprocal slopes. Negative so that they'll go opposite directions, reciprocal so the rise and run get traded out. So for instance, if I had y is equal to 5, 6x plus 3, a perpendicular line would not have 5, 6 slope. It would have the negative, since this is positive, this would be negative, reciprocal, negative 6/5 x minus 2,000. I don't know. It really doesn't matter what the number is there, right? As long as the slopes are negative reciprocals. What if I had y equals negative 4/7 x plus 2? What would be a perpendicular line to that, Maddie? Right, positive 7 over 4x plus 3, for instance, right? Does that make sense? A negative reciprocal? What would be the negative reciprocal class of 3? That would be the negative, but it wouldn't be the reciprocal. Negative 1/3, right? What would be the negative reciprocal of negative 2? Positive 1 over 2, right? So negative reciprocal slopes. We could see it this way. Supposing I gave you this equation, x plus 3y equals negative 2, and 3x minus y equals negative 1. Are these going to be perpendicular lines? Well, to find out, we have to know what the slopes are. And see, are the slopes negative reciprocals? Right? That's what it comes down to. So to know the slope, I first of all have to get the y by itself, move over class the as a, to get 3y equals negative x negative 2, and then divide everything by 3. Really, I only care right here that I divide by the 3. I can see that the slope is negative 1/3. All right, here, to get the y by itself, there's a shortcut. It's double switch, right? 3x plus 1 equals y. Are the slopes negative reciprocals? Then the lines are going to be perpendicular. How about this? If we had a line that goes through 3, negative 1, negative 1, 2, and we had another line that goes through 3, 2, and negative 3, 6. To determine if these are parallel or perpendicular, we'd have to find the slopes. So let's find the slope. How would we set up the numerator? 2 plus 1 in the denominator? Ooh, careful, negative 1, negative 3, and that would give me 3 over negative 4. Okay, let's find this slope. Set up the numerator.
6 negative 2.
And in the denominator.
Negative 3, negative 2.
And that would give us,
4 over negative 6.
oh, are those going to be negative reciprocals? Then are those lines perpendicular? No, they're not. So, lines can be parallel, class, if their slopes are the same or equal. Lines can be perpendicular if their slopes are negative reciprocals. Exact opposite means negative reciprocal. Class, what two things must be true of slopes for lines to be perpendicular? Negative reciprocal. Negative means inverse, reciprocal means flip it, right? Negative reciprocal slopes. That class, perpendicular lines, negative reciprocal slopes. You're going to read over some things along those lines in your homework tonight and answer some quick questions in addition to doing a handout. Your homework for this evening is to read pages 115 to 118. Read pages 115 to 118. On page 119, answer questions 1 through 4. Questions 1 through 4 are going to be yes or no. Yes or no. Okay? Page 120, 21 through 24. Page 120, 21 through 24. Again, you're going to answer the questions yes or no. Okay? And then, so that should take very little time on your part. In anticipation of the test coming up on Friday, I'm going to give you a handout. Now, this handout, we're not going to go over it tomorrow. We're not going over this until Thursday, which is lesson 123. Okay? But I want you to complete this handout for Thursday. Complete this handout for Thursday. So you have 2 days to work on it. But these are some word problems that we worked since the last test that we need to have ready to go for Thursday. We'll go over it in our test review that day. Have a wonderful rest of your day. You are dismissed.